one of the homework problems 2 nights ago. Does that look familiar? Did I get it wrong? Is that one of them? I think it might be one of them toward the end.
Yeah.
Is it?
It's number 13.
All right, number 13. Great. And you look at this. So, am I doing the right thing?
You talking homework here?
Yeah, 2 nights ago, right? Is
Number
that okay?
70.
I know it doesn't. I know I said I wasn't going to, but I actually want to use this as a springboard. So I look at this, and the first thing I ask is like, "Hey, nth term test, right? What's the nth term go to?
Infinity.
As n gets really big, what's the nth term?
the
Zero.
term.
The nth term gets closer to 0. Does that tell me anything?
It
Tells you something, but you still have two
could be
choices.
convergent, but it's not proof.
Right. We don't really know. If it didn't go to 0, it would definitely diverge. But if the nth term goes to 0, it actually doesn't tell us anything, right? I could still have a divergent series here, or it could be convergent. So it really doesn't tell me much. The next thing I think about, well, if the nth term test doesn't work, what else am I hoping that the series might be? Because I know the series really well.
The harmonic.
Say again.
Positive and
Yeah, hold on to that one. That's the next thing I'm going to think about. What other thing am I hoping that it might be before I even start thinking about that? Say it loud and proud.
Geometric.
Geometric, right? I'm hoping it might be geometric. It's not. Done. So the next piece I'm thinking, hey, is it something I can integrate? And if the answer is yes, then Julian says it has to be.
continuous, positive, and decreasing.
All right, and this is continuous, positive, and decreasing. And I can integrate it. So total candidate for the integral test. I want to show you another way we could think about it. And I'm not saying you have to think about it the way I'm going to show you, but the strategy I'm going to talk about will be helpful for other problems that you can't integrate. Okay, so how about this? Would you agree that this is the same as, that's a multiplication. Am I so far so good? All right. Now, I'm just going to focus on this piece. Okay? Would you agree that that's bigger than 1 over n?
Yes.
Yeah.
Tell me why. Greg, why?
Well, because n is on the bottom, and the bigger it gets, that makes the actual numeric value smaller.
Okay, so if I subtract a half, what's it going to do to the denominator?
It's going to make the
Make it
denominator
smaller.
smaller.
Smaller, so it's going to make this whole number bigger. Is that okay? Is that good? All right, so Greg just did the comparison test. He just said, hey, I'm going to compare this to something I know. Well, what do you know about that series? What do you know about 1 over n?
It diverges.
It diverges. All right, it diverges. And that's actually that one, that's that really special case. It's called the harmonic series. It diverges. You could also tell me it's a p series where p is equal to 1. So it diverges. Okay? Hey, what's something bigger going to do?
It's going to diverge.
It's definitely going to diverge. What does multiplying something that diverges by a half do?
Just makes it smaller, but it still diverges.
Yeah, diverge
It's
means
a
like
constant.
going off to like infinity, right? Getting bigger and bigger and bigger.
Use the strategy.
Multiplying by a half is not really going to do much. Okay?
Well,
So-
so no matter what the thing in front is, it would if it was like 1 over 32, would it still? I think it
Yeah.
would. It's like just a constant.
Right. So it's just a constant. And if I'm talking about something a series that diverges, I'm talking about a series that like goes off to infinity. I'm talking about area that's infinite. Multiplying by a constant, whether I multiply that constant is 1 millionth or a million, it's not going to change that magnitude. Okay? Which is pretty crazy, right?
Yeah.
Take an infinite number and divide by a gajillion. Still goes off to an infinite number. So, hey, by this reasoning, this is called the comparison test, I can say this diverges.
Now, why can we say it diverges? Because it's greater than
Something that we know. that also diverges. Now,
What about that 1/2? Won't that 1/2 have an effect anyway?
We just went over that.
you can talk to Lena. She'll catch you
well,
up.
I was listening the entire time, but I guess I must have totally missed it. 'Cause
And the beauty is you can go back and rewind, right? It's nice.
It's
So
recording it.
this is great so long as what has to be true about this?
It has to be able to like factor into it.
If you can pull out the half.
Yeah,
It
yeah,
has to
yeah.
be greater than 1 over
Yeah,
n.
yeah,
If
yeah.
it was less.
Yeah, all right, a bad question. Terrible teacher question. It's great so long as whatever's here, you can compare it to something that you know, right? This whole thing does you absolutely no good unless you have something you can compare it to. Here, I was able to compare it to the harmonic series, right? It might be nice to be able to compare this to like a P series, compare it to a geometric series. Let's take one where we might compare it to a geometric series. All right, so I'll pause just for dramatic effect. And we'll take a look at another one. Oh, I didn't do anything. Let's see. 2 minus 1. Hold on, I know I can do this. All right, I think that'll do it. Yeah, great. Hey, I have something and I want to figure out if it converges or diverges. Can you integrate that? No. Integrating that would be really hard. Nth term, when n gets really big, what happens to
2/3.
try again.
I think it goes to 1.
So you're multiplying by 2/3.
Or not.
it goes to infinity.
Is it?
I have
Doesn't?
2 to the n and 3 to the n. Which growth dominates?
3 to
Oh,
the
the bottom.
3 to the n. Right? 3 to the n is going to get faster, much
Doesn't go to 0.
going to get faster. Oh, get bigger much faster than 2 to the n.
So it does
this
go to 0.
goes to 0.
Does it?
The nth term test tells me nothing. If the nth term goes to 0, I don't know anything. It would have been nice if it went to like 5. Then I could say, hey, it diverges. But it doesn't. It's not straight up geometric, but it's looking like maybe I can compare it to a geometric. Greg, you had a question that I cut you off on. Sorry.
I was gonna say I just remember something in the past where you look at it like so if you had an exponent that was if you added like something to the x on the top, something to the x on the bottom. Just I think it was dealing with asymptotes, like you would have one at 2/3.
So
Where if like the
This is- this is what-
something else.
I think I know what you're thinking of. I think you're thinking of something like,
yeah, in that case it would
okay,
be
in that case,
Yeah.
you're absolutely right. That approaches in the long run 2/3. Here I'm not talking about a linear relationship. This is exponential, right? And that bottom exponential is going to dominate. All right, so here's what I'm going to say. Hey, how would this compare to if I make the numerator smaller and the denominator bigger?
It does the same
It's
thing.
the same.
Just in a
So how does that compare to this?
different thing.
Oh. It's the same thing if you're finding the
Bigger.
conversions.
Well,
ratio.
it's just that the numerator gets smaller quicker in one of them because you're subtracting.
So
it.
Alright.
it's smaller than.
Do you agree that 2n minus 10 over the quantity 3n plus 10 is smaller than 2 to the n over 3 to the n? I'm making the numerator smaller. What does that do to a number?
Makes it small.
Makes it smaller. I'm making the denominator bigger. What's that do to a number?
Makes it small.
Makes it small, all right? Now I would agree, maybe in the long run, the minus 10 and plus 10 don't really work, but no matter what, this is going to be less than this. Okay, well, another way of writing 2 to the n over 3 to the n is 2/3 to the n. Hey, if I put a 1 out in front, that's a geometric series. R equal to
2/3.
2/3. What do you know about a geometric series?
Ours is
Geometric, r less than 1, so what does that do? It converges.
Converges to 1 over 1 minus r.
Yeah, and to be honest, I don't even care what it converges to right now. We might later, but right now I just care it converges. Well, if this converges, what's something that less than it have to do?
Also,
Has to converge.
are we going to get into a situation where we do a comparison like that? It's
Yes,
the opposite.
absolutely. You're going to compare something. You're going to say, hey, it's bigger than it's smaller than a diverging series, and that's going to tell you nothing. And you're just going to have to say, hey, I either need to think about something else I can compare it to, or come up with another way of looking at this. Okay, so that happened. Actually, to be totally honest, in my other class yesterday, it happened to me twice. I was like, oh, that was not a good comparison at all. So, Alina, then maybe David, I wasn't sure if you were stretching at a question.
So when both of those equations converge to the same number, do the minus 10 plus 10 make a difference enough that it converges to a different value?
That is a fantastic question. All right, so I'm going to say the minus 10 plus 10 probably do not matter. What it, I can't answer it. Sorry, I'm not going to give you a wrong answer because I feel like the first term, that minus 10 plus 10 makes a very big difference.
Yeah.
Right.
Yeah. But in
The
the
second
long
term-
run,
So I feel like in the long run, both of these series, you end up adding smaller and smaller numbers. But don't forget, a series is the sum of all of the terms.
oh,
Right? So I feel like that first, second, third term, it's going to make a difference. Don't quote me on it. Just a gut feeling. Okay? And again, I'm going to say this. Right now, don't care so much what it converges to. Just care that it converges.
No,
Stretch
it's not
question?
stretching.
Okay. Good place to pause, though. So we saw one example where we were able to compare something to a series that we knew diverged. Now we were comparing to an example that we knew converges, but I need to say this. It's hard to figure out what to compare it to, right? So the comparison test is great because it alleviates some computational math, like, hey, I don't have to use the integral test. So what you said, Julian, you like this? Or you said you didn't like it?
Yeah,
You're all over
I
this.
used this a couple minutes ago.
Great, right?
I'd
It's
do the
awesome.
opposite. I'd rather
Agree, right? Like, so there's this thing where, like, hey, if you tell me what to compare it to, fine, I'll do that. But if I have to come up with what to compare it to, that's really hard. I'd rather just have a rule where I can plug in. So I think both sides of the coin are completely valid. Emily and then David. And then we'll do some more.
What happens if neither test work?
Then you need to come up with something else.
Is there
Right.
something else?
Yeah, we got like 3 or 4 more. And then off into the great,
Blue Wonder.
yeah, that's what I wanted to say, of college calculus. Maybe even put some more tests under your belt. Yeah, go ahead. And get out your classwork while we're doing this.
So if it's greater, whatever it is, it's less than a diverging series.
Doesn't tell us anything.
And if it's greater than a converging series,
Doesn't tell us anything. We picked something wrong to compare it to, and that's what I was saying. I did that twice yesterday in my other class. Not one of my finer moments. I've been off in that other class. I don't know why.
It's because it's the other room.
Something's up. Something's up. Yes, you are. Oh, I didn't say that. I was kidding. You're both all great classes. All right. All right, let's see. Now, here's the deal. Oh, boy. I changed your classwork a little bit because
Don't
I-
print out a new copy. It's bad for you, man.
yeah, you don't have to. I did change your classwork a little bit. I think I did. I think like these might be different, and that's okay.
what reason did you change it?
Because I found out that I used some from a course where I did an even another test, which I'm not doing this year. So it made it hard to talk. It made it hard to talk about. We ran into an instance
Okay.
where, hey, we were comparing things to, hey, it's smaller than diverging. What's that tell us? Well, if you looked at the limit comparison test, we could do that, but we're not talking about the limit comparison test. We're just talking about the comparison test. So, hey, let's pick like maybe 1 or 2 from 9 and maybe 1 or 2 from 10, and then I think we'll wrap up and start talking about homework from last night. All right. So go ahead. Pick one that we maybe could look at from 9.
B.
Yeah.
B?
D looks tough.
All right.
It's-
Take a look
Actually,
at
D
B.
looks tough too.
All right, maybe we'll try to look at both of those. We'll see what we can do. All right. B. Actually, just grab one. Okay. Oh, boy. Oh, help me here. There we go. Okay, so, hey, I have this nth term. What's the nth term go to?
I think
Well, something huge minus that 5 doesn't matter. So the square root of something huge, still something huge, goes to 0.
no.
So probably the numerator dominates here.
Oh yeah.
Probably, right? And probably. Oh yeah, this doesn't go to 0, does it?
No.
We could probably say it diverges right off the bat.
Yeah.
All right, that's great. That's nice. Finished. Now I'll still show you the comparison test with this, but that's nice. Can you integrate it?
Probably not.
This is going to be really tough to integrate because I don't have the chain. One's not the chain of the other. If you can recognize the chain of the other,
Yeah.
you think you see something that I'm not
No.
seeing? We could, or maybe you know what? This might be U substitution. Like if you had n times n minus 5 to the negative 1/2.
So you make the
So-
the minus 5.
Right. If you let n equal u minus, if you let n minus 5 equal x, like so maybe we could integrate it. Wow, this is a terrible
Yeah,
example.
I would not.
Or maybe it's a great example. Maybe it's an example that you can do so many different ways, and that's really rewarding. All right, so.
Good recovery.
I thought so. Okay, so I would love to be able to compare this to something. Is this definitely? How would you compare it to that?
I mean, it's the same situation. It's the other one's converging, and this
Well, tell me, is this
One's
bigger or
bigger.
smaller?
It's bigger.
is bigger.
This one's bigger because the denominator is.
Smaller.
All right, is that okay? So this is bigger.
But we know that the other one's converging. Or divergent, sorry.
All right, are we okay with that? So here's what I might say. This is the same as n over square root of n. So isn't that equal to subtract the exponents? Whoops.
Oh my god, now how are we supposed to see that? I mean, like, in
Wait, really?
retrospect,
Subtract the
Well, I mean-
exponents?
So it's end of the
N to the
One.
n times.
Into the negative 1/2.
So if I multiply, that's just n to the 1/2, right? Yeah, now it's really easy to see that the square root of n just gets bigger and bigger and bigger. That diverges. So if I know that this is bigger than something that diverges, I know it must diverge.
What a great problem.
That's enough out of you. Let's try B. D. You wanted to do D?
Yeah, we did.
It's here somewhere. Hey, what are we going to compare this to? What do you want to compare that to? Thoughts or ideas?
Well, what do we know about what Lynn
It always
does to
gets
a number?
faster. It's bigger.
So we need to compare it to something that we're familiar with that looks a little like this. Do you have thoughts about something that looks like ln of n over n?
I was going to say e to the n over n.
Just natural log of n?
You just have
How about that?
That way.
That's a good one to compare to.
and how do we know that? I mean,
Well-
like in
Tell me this. Do they look similar?
Yeah, they look
Looks
similar.
all right. So, and here's how you know. You know you have to compare it to something that you know what it does well. What do you know does? What do you know? What functions are you most series you're most familiar with? Well, geometric. Does it look like I'm going to compare this to a geometric? Probably not. And then the only other ones you really know are like your p series, right? Like 1 over n squared, 1 over n to the 1/2. Well, if I have to compare it to a p series, this looks to me most like 1 over n. And this is a great problem because I'm going to ask you this. How would you compare these two? What can you say about ln of n over n?
Much bigger.
Much bigger?
Wow. Bigger.
Well, at
Ln
one
of n
point they're
is-
equal.
Yeah.
Yeah.
Because ln of 0 is 1.
Yeah, absolutely. So they're actually
we-
equal, but
But
what
n
ends up
never equals
happening?
1.
What ends up
N
happening?
starts at 1 and never goes to 0.
All right, fine. But what ends up happening when
Yeah.
when n is like when n's 100 or 1,000? Is it bigger?
Yeah.
Yeah. It's
Okay.
bigger.
So this actually brings out another great point. When you're comparing series, or even if you're doing the integral test, it doesn't matter where you start. We don't have to start at
You
1.
want to find something that's greater than
It-
a diverging.
And what matters is what happens in the long run. What happens, if you think about the integral, what happens in the tail, right? So if you have something that diverges or converges, everything from here to here doesn't matter. That's just finite area. What matters is what happens in the tail. So does the tail converge or diverge? And that means that you can start looking. You don't have to look at n equals 1. You can start looking at n equals 10. You can start looking at n equals 100. You can even start looking at n equals 1,000,000 off to infinity. The important thing is the red, what happens to the tail. And hey, this is bigger than a diverging series eventually. And if it's bigger than a diverging series eventually, it's going to diverge. Okay? Quick questions. What do you think we're going to compare that to? Thoughts or ideas?
Can you just do 9 over n and 10 over 10 over 10 over n?
Probably going to compare it to somehow 9/10 to the end because it's geometric. So you're going to have to tell me, is it bigger or smaller? What do you think you're going to compare this to?
Well, n to the 1/2 over n squared is 1/2 minus 2 is... No!
No, come on, you're right there. All right, so whatever. You're doing
Negative
great.
1.5.
So
So negative 3 halves.
n to the 3/2. We're going to compare it to that. You got it! This is a p series. What do we know about the p series? This is going to
P is greater than 1, so it converges.
converges. So what we're hoping in the comparison is that this is less than this. Now you're going to have to do a little work. All right.
Yeah.
I definitely want to stop and I want to talk about homework from last night. All
The
right.
denominator is bigger, so what?
Right. All right.
If it's less than the fractions, then
So you asked me to find out what my dad did.
Oh yeah.
So